Okay, we'll get there.
Yeah, learning outcomes.
Okay, we're there.
And this is the version that Jean-Claude mentioned that is effective of June, and it's basically providing some corrections that were a consequence of the fact that when the study guide and the learning outcomes were submitted, they were modified a little bit, and typographic errors and loss of fonts and a few other things were a consequence of it. So in the version that was before this, sometimes you didn't see Greek letters and formulas the way they should have presented themselves. And I think the learning outcomes, the only difference now is that there's the version 2011-06 at the bottom. You'll notice there's quite a few items in the list of essential reference material. Most of these you can download from sites of one sort or another. And the ones with the pound sign in front are available through the CBEP's website. The only one that seems to be oddly labeled, and again I think this was a typographic error, is the one by Kissam down here, 1956. On the CBEP's website it's KIS space 1986. So we just gave old Philip an extra 30 years. The supplementary reference material are simply items that you would probably find useful if you happen to come across them. But all of the examination questions and the study guide based on the essential references. Now, the study guide, we'll start to go through the questions then. In the order that I've given in the webinar outline that was just up a few minutes ago. So we're following under design, simulation, and error analysis. And that takes us to the first study question. And I guess this is another major thing that has happened in this particular version of June of this year, is the fact that I've labeled the questions sequentially so that we can pick them out a little more readily than we could in the earlier version. So the SQ numbers are the ones that are in this particular version of the study guide. So I have noticed in the forum there have been discussions concerning certain study questions and some examination questions, and this particular study question was one of them. And the answer is 130 arc seconds at each of the two angles. So we have a formula that we can find in either urban surveying and mapping and in some of the other Chernovsky publications that would allow us to calculate it, and you realize that the effect of refraction is an arc across the bottom of the block with the same error in both angles, so the two of them together would be 260 seconds, which if you divide that by 60 would be 4 minutes and 20 seconds. Study question 2. And I would like you to, if you have any concerns about these, to send comments to Jean-Claude so that we can pause if necessary, but not pause quite that much.
Or you can raise your hand.
So study question 2 is basically asking if you have the calculation of refractive index and want to find out what variation in temperature from a design value, we would then have to worry about the meteorological correction. Now, if you look in the manuals for EDM, or for the electronic distance measuring portion of a total station, it will usually give the conditions under which the display gives the proper value. And commonly it's at 12 degrees Celsius and standard pressure and 60% relative humidity. So if you're working in that temperature and pressure, then the display is correct. But as you get colder or warmer from that, you may have to start worrying about the meteorological correction. The rule of thumb is 1 Celsius degree and 3 millibars would be 1 part per million each. So if you look at this particular question, it says if we can tolerate a variation of 2 parts per million, how much variation in temperature or pressure can we have from the design values, which are the ones given in the parentheses? And so it's basically 2 parts per million times 2 degrees, which would be 2 parts per million times 1 degree would be then 2 Celsius degrees either way of 12. And 3 parts per million, 6 parts per million then total from away from the standard value. Now, that wouldn't be enough as an answer. However, if you look at, for instance, in the most recent exam or the one that's currently online, you'll notice that there is a refractivity. That's where the formula uses a capital N is equal to a 3-digit number minus a calculation that uses pressure and temperature.
James?
Yes.
I have a question.
Yes.
From a candidate.
Okay.
For the first question, should we be using a straight gradient for the temperature as we move away from the wall?
Yes. Unless you're told otherwise, you would interpret the gradient as being linear. Now I try to scroll up here. There we are. So we have in this first question that there are 2 temperatures measured. One of them is at the building face and the other is 1 meter away. So obviously the building would be warmer than 1 meter away from it. So the 35 Celsius is at the building, the 30 Celsius is 1 meter away. So if we're running at a line that's half a meter away, the temperature would be halfway between those two in proportion to the 0.5 to 1. Which would be 32.5. And the gradient would be 5 degrees, 35 minus 30 divided by the 1 meter, which would be 5 degrees per meter.